We think you can that?
Yes. So I'll talk first. Okay. Yeah. Thank you. So yes, thank you for the invite. Thank you for the previous talk. I'm pleased to hear that data engineers are needed because I'm a data engineer. It's good to know. I'm Andy South. I'm a data engineer at UCLH. I'm going to be doing this with Kawsar, who I've just met in person for the first time. So good to meet you. And forgive me, I'm slightly nervous and slightly excited because this is the first time I've given a talk since COVID. And I've never talked on a stage with a Steinway before, which is sort of slightly intimidating. But we're going to be talking about our tools for extracting data from our source systems, the electronic health record at UCLH, we've got EPIC, into the common data model. So I'm going to be starting talking about this top part, which is mostly about structured data. So we have an extraction system in R, and then I'm going to hand over to Kawsar, who's going to talk about the fancier part, where they get the data out of the structured data out of the unstructured data. So we're working on a range of projects which we're extracting OMOP for. These are my lovely colleagues, and quite a range of people in there. So, data engineers, clinical experts, data scientists, quite a mixture. And we're led by Tim Roberts, very nice man, and he kind of started this particular extraction system that I'm going to be talking about. And so the idea, the practice is that we're providing high quality extracts from a single pipeline, and we've got per project settings. And it's been developed on a kind of per project basis. So as we've got particular project funding, that allowed us to develop particular components, but then we're not just providing that for that project, we develop the code that then we can reuse in future projects. So we're ratcheting up all the time. Gosh, that sounds really like we're making progress, but it's good. So this is an example of the one of the project settings files. So within that we can set the dates, which OMOP version we're using, whether we're excluding national data opt-out, whether we're including NHS numbers and MRNs and that kind of thing. So if we're doing it for an internal client, then we can include those things. If we're doing it for external, we can exclude them. And so we can just change the settings file, press a button, and rerun it to get a slightly different extract. This is the coverage across the across the different OMOP tables at the moment. So we've done quite a bit. There's still plenty to do, keeping us busy. And so this is mostly based upon R. At the moment, the code is in a private repository. We're hoping we might be able to open source some of it at some stage. Because I'm here, I'm going to use this this is a little side project of mine. I'm relatively new to, so this is completely open source. I'm relatively new to OMOP. When I started, well, and still now actually, all these numbers, they just don't mean anything. All these, how do I understand all these identifiers, all these IDs? People would give me something and say, why isn't this joined to that one? It's just a number. And so the main idea of it was just about making it easier to get the names from the IDs to make it a bit more understandable to people, well, to me mostly, but then also to be able to explore the hierarchy in a sort of a reproducible way, to do things that you can do in Athena, but to be able to do it directly from R. And I mean, how I find a lot of the Odyssey tools is there's some amazing stuff out there, but my boss asked me to do something, like by tomorrow, and I go and try and look at the Odyssey tools, try and work out, is that going to help me by tomorrow? But it takes me until tomorrow to work out what they do, so, and then I think it does lead to a lot of reinvention of the wheel, probably, but yeah, this does what I want. Right, so I've got a question for you. In fact, it's a little competition, which is, how many OMOP concepts have got Oxford in the name? So these are all the OMOP concepts that have got Oxford in the name and their immediate ancestors. And also this visualization is probably not particularly useful here, particularly given that this projector has a weird thing where it misses out one colour, I think, isn't it? But you can imagine how these kind of visualizations could be useful. So yes, come up to me during this meeting, tell me how many concepts you think, and the closest to it, the real number, from actually not the most recent OMOP version, not the one that was updated last week, but we'll get a tiny prize. And if you actually download my package, you can, with a command of 16 characters, you can get the exact answer. But if you all do that, then I'm in trouble because I don't have enough prizes. Right, so just a bit about what we think some of the strengths at UCLH are. I'm aware that I'm eating into Kawsar's time, so I'll kind of stop there and over to you.
Okay, my name is Kawsar. I'm not part of the OMOP officially, but I'm working on a separate thing called CogStack. CogStack, it's a natural language processing platform whose objective is to help researchers to extract structured data from the free text portion of the EHR system in any hospital. So just to motivate why we use something like CogStack, data in any EHR system can be thought of in terms of two categories. You've got your structured data, which is what you guys are experts in, and you've got the unstructured data, which is things like free text, images, scans, that sort of stuff. So these are data items which contain structured data, but they're not structured yet. And so there are some estimates, I don't know where they come from, 80% of any EHR system is apparently unstructured. So there's a lot of value that's locked away. And so the CogStack platform was developed to tackle this problem of unlocking this value. The CogStack platform was developed at King's and it's been rolled out to a number of sites across the country and internationally. It tackles two problems. The first is the data ingestion and harmonization problem, which is hoovering all the free text data in a hospital into one location so you can interrogate it. And the second part is having deploying set of NLP tools which you can use to then interact with that data. I'm not going to link it on this slide, so I've got a few more to go through. At UCLH, we've deployed it as such. We've got a pipeline that pulls in all the free text data from the EHR record on a daily basis at the start of the day. So we're looking at things like clinical notes, imaging reports, letters, hematology reports, that sort of stuff. We also have a pipeline that pulls in the archive data record as well. So this is stuff going back before 2019 where UCLH was using Word documents and PDFs, that sort of stuff. And so we have an engine which scans the contents of these documents and pushes them into our CogStack platform for interrogation. So following that, we have a couple of natural language processing tools which you can use to interact with those, and those are constantly evolving as time goes by. We've now started to do things like large language models and that sort of stuff. But I just want to talk about the most popular one, which is called Medicat. And what Medicat does is that it extracts SNOMED concepts from a passage of text. So if you feed it a passage of text, it will scan over that text and pull out any SNOMED concepts that it thinks are in that text. So you can see an example there. It says during the night, HR was in the 40s, 50s. The patient was at 8 milligrams HR. And what Medicat does is it will read that text and pull out all the various SNOMED IDs from there. Interestingly, what it also can do, we can disambiguate. So, for example, HR, you can see it's appeared twice, but they're linked to two different SNOMED concepts. Medicat's able to look at the surrounding text and figure out which assignment to make based on the surrounding words. So the first one's clearly hard, the last one's hour. Medicat also comes with an additional set of meta models which you can use to pull out meta information once you extract the concept. So to give an example, the patient is not asthmatic. The first step Medicat will take is it will detect the asthmatic SNOMED concept and then also figure out if it's negated in the context. So that's meta information you can feed in and use for downstream processing. This is just a slide to say how much free text data that's been ingested into CogStack so far. The last count was 30 million, but that's obviously changed since I've made this slide. This slide's about a year old now. platform as part of a number of clinical projects, the vast majority of which are Medcat use cases. So these are clinicians who want to analyse their clinic retrospectively using Medcat, so they'll end up sending timelines for patients at an individual population level. One interesting project we're working on now is what's called a loss and follow project. So these are patients for whom there has been no next clinical action booked in the system. These patients don't have a blood request order on the system or a discharge order on the system. However, the clinician has noted that in the notes. So there's a discrepancy between what the clinician wants to do and what they've actually done in the system. So this box stack tool we've developed is trying to close that loop to make sure we don't have patients lost and followed. So this just give you a flavour of sort of the breadth of coverage that box stack is being used for. In terms of the OMOP stuff, which is what you guys are interested in, we're working on a pipeline with the OMOP team to make sure that the data that's currently in COGS actually, all the NLP-derived annotations, can make their way into the COGS, into the OMOP data model. And we're currently working on a pipeline. So it's not complete yet, but over the next few months, hopefully,